Hello guys, welcome back to my channel, and today we are going to discuss about thermodynamics. And thermodynamics is actually a subject which deals with the heat, energy and temperature, and whenever they are in a constant temperature and constant heat and conservation of energy, that there are some laws which could describe these three things, and they are actually divided into four laws. They are the zeroth law, first law, second law and third law of thermodynamics. Normally, first of all, what is thermodynamics? It actually deals with the heat, energy and temperature. So these four laws describe the thermodynamics, like they are described into the laws. So first we are going to discuss about the zeroth law of thermodynamics. So right now, zeroth law of thermodynamics, it states whenever two objects, if you take any two objects and they are in thermal equilibrium. Now what is thermal equilibrium? Thermal equilibrium is nothing but whenever two objects or any other bodies are in equal temperature. So they don't describe in the temperature, like this temperature is passed to this temperature. If this is in a 50 degrees Celsius, then this will also be in a 50 degrees Celsius. It's kind of big, but to just simply say, let's take an example. If you take a body as A and another body as B, and let's take a third body as C, or you can take just multiple, just kind of taking more than by. Now if these both are in thermal equilibrium, like if this is at 50 degrees Celsius, then automatically this B is also in 50 degrees Celsius, and this B and C are in thermal equilibrium. That means indirectly this is in 50 degrees Celsius. Then these both will also be in thermal equilibrium. That's stated in the zeroth law of thermodynamics. Now next we are going to discuss about the first law of thermodynamics. In this we can just simply say that it's conservation of energy. It tells how the energy is transformed from one body to another body in equational ways. Yeah, in this we can simply say that energy, it can neither be destroyed nor be created. It's the conservation of energy, like conservation of many things are there, but conservation of energy it follows. Conservation of energy, like I think many of you would heard about this in the work power energy chapter. Conservation of energy, it states that energy can neither be created nor be destroyed, but it can be converted from one form to another form. Like if you take many examples in our daily life, like energy is never being created or it cannot be destroyed, but it can just be converted from one form to another form, like from kinetic energy to potential energy. When you throw a ball, energy is not created over there, but the potential energy is actually converted into kinetic energy. Like that, this is followed by an equation. So there are normally Q, okay wait a second, it's small q. Q is actually followed with plus in front of it and minus when it's endothermic. So endothermic reaction is when the heat is released. So if the energy is released, then it's Q plus, and if the heat is not released, it's an exothermic, then it follows the same, but it's Q minus T. In this, delta U is the energy, it is the initial energy, and the Q is the heat released or absorbed, and T is normally the temperature. Normally the temperature would be at the constant and it would be changing with respect to the time. So next we are going to discuss about the second law of thermodynamics. Now second law of thermodynamics states that the temperature in any body, it will be changed from that cooler object, hotter object to cooler object, but it cannot be in a constant way. Like any of the temperatures, it will finally go to the absolute zero temperature. So there is no object it's that cooler or hotter. The ice, it finally melts and converts into water, and when it is at the vapor temperature, it does convert into. Yeah, this is stated in the second law of thermodynamics that any body will be converted into the zero temperature. So there is no body at high degree Celsius or there is no body at low degree Celsius. Finally, that's it. What should I say? Yeah, and we can see about the second law of thermodynamics. It is represented with S, and S has a equation with Q by T, which also represents the heat and the temperature. And this S is actually the temperature changed, the change in temperature. And second law of thermodynamics, it is actually used in our daily lives also, as you know, any of the objects will be reduced to their actual temperature. So in these three laws that we had discussed right now, they do come with the heat, energy and temperature as we're discussing right now. So these laws are actually related to the thermodynamics, which states that it is deals with the heat, energy and the temperature, which could be constantly subjective and changeable. That's it.